My name is Mohit Raj. I'm studying in class 10.
My name is Jatin. I am studying in class 10th.
My name is Yashas. I am studying in class 10.
We are from Government High School, Koila. So, our project name is WaveWatch. It's an IoT based automatic pump controller.
Problem statement. Due to the lack of efficient water management system, farmers face difficulties in optimizing irrigation practices. This leads to water wastage and impacting farmers' livelihood and environment concerns. So for this, we have selected some targets.
Our targets are small scale farmers and the large scale farmers who grows different kind of the crops in their farm, and some other users or places like greenhouses and some schools and some houses where the water management is not proper. So in this we have a solution to save water.
So, let me show the solution for this. Here we can see that here just imagine that these two objects are the tanks. Here this is the lower tank and this is the upper tank. Here these tanks are the real life tanks that we use in our houses. This tank will use in the above the terrace. The water from the lower tank goes here, the pump will be there. So the water from here will be pressurized from the pump and will be flowed to here, to the upper tank. And here we have used ultrasonic sensors. What this ultrasonic sensors will do is, when the water level, it will detect the water level between the level of the water and the sensor, and by doing this it will calculate the percentage. That means how much water is present in the tank, and it will send to this microcontroller, the controller box, and this controller box will process the data, and based on the water percentages in the tanks, it will operate the pump. And as you can see, let's visualize this bulb as a pump. So let me show a working demonstration right now. Here, as you can see the real working app that we have coded ourselves. Here you can see all the three water percentages of the tank, and here we have designed user interface in which we can control the pump easily using the two buttons over here. With just the click of a button, we can make the pump on or off, like this. If now the pump is off, I press the pump on button, we'll see that the pump will turn on. And in the same way, if it make it off, then it will turn off. And there are many other settings that we can use in this mobile app. Yeah, as you can see that how much water percentage is there in the lower tank, we can see it over here. If I just move, if you visualize this as a water level, when the water level rises up, we can see the water percentage in this also increases. So this is just the working, but the main logic of the system is that here the pump will be there. So when the water level will be lesser than 10%, means when it is lesser than the pump's level, then automatically the pump will turn off. By doing this, the pump will not get damaged because of running without any water. Running without any water will damage the pump. So we are putting a lower limit over here, and in the same way, when the water level reaches to 50%, then the pump will turn on. Then after the pump will turn on, the water from here will flow to this tank, to the upper tank, and when the water flows to here and gradually increases, when it reaches the overflow limit, that is the 90% mark, then automatically the pump will turn off. By doing this, the water will not be overflow and water can be saved. And in the same way, after the pump is off, there is also a 50% limit. When the water is used to the domestic and other purposes from this tank, the water level reduces until 50%, then again the pump will turn on. So this is the logic cycle. After that the cycle repeats itself Then finally the water level over here will decrease 10% and the pump will turn off. This is our logic cycle of the WaveWatch project. Thank you.